Hello ASs. Just when you thought that you had escaped all your teachers, I have returned via the wonderful technology that we have available to us. So I'm going to go through chapter 9 with you today, and we're going to do the exercises that I gave you for homework the other day. So let's have a look at number 9a. Just let me get my textbook here. Alright, so the first question said name the angles subtended at the circumference by the minor arc AE. Alright, so what you want to do is go and have a look on your diagram there and just find the points A and E. And if you do, you'll find that the points A and E join on the circumference at C. So the first angle that you want to name is ACE. If you're not sure where that is, move your fingers along those three letters and you'll see where that angle is. But A and E can also go to the point D on the circumference. So another angle that is subtended by that minor arc of AE is the angle ADE. Now some of you might want to name the AFE angle. And that one is not subtended by the minor arc because it is subtended by the major arc AE. You see, the angle F on that one is on the other side of A and E, and so it comes from the major arc, which is the other bit of that arc or of the circumference part that has A and E as points on it. I hope that makes sense to you. Then, the major arc AE is the one that B actually answers, and so therefore you wanted to name AFE as the angle subtended by the major arc AE. What about number C, which says it's at the center by the minor arc AC? So now go and find points A and C and see where those 2 points join to the center. Well, the angle that they make is AOC. And then at the circumference by the major arc AC, well, we need the major arc, so that's the bigger part of the circle. So AC, look, if you go all the way from A and you go right around anti-clockwise around the circle, you'll get to C. That would be the major arc, and so the point that it goes to is B, and that would be the angle ABC. And then we've got at the center, this is question number 1E, at the center by the minor arc CE. So find C and find E on your diagram, and then you want to go with the minor arc there, so that'll be on the smaller part of the circumference of the circle, and that line goes to the center at O, and so that's COE. And then we've got at number F, which is at the circumference by the minor arc CD, and so that will be the angle CAD. And lastly, we've got question G at the circumference by the minor arc BC. So BC is that very short little line, and being the minor arc, you're looking at the little part of the arc length just from B to C, going clockwise on the circumference, and that line gets to the circumference at no point. So this question cannot be answered because there is no arc that goes to join at the circumference from there. You might want to say, well, what about the point E? But the thing is, only the line C goes to E, not the line from B. Okay, so there's no point where it meets. So the one I'm looking at, though, however, does go to A. Can you see that? So if you go from C to A and B to A, then you have a line that joins, and so the angle there must be CAB. All right, I think we've got all of those. So let's have a look at question number 2. Now, I'm going to do this one on the whiteboard, which you can see by you as well, so that you can see how this goes. So let's draw what we have here. It says that AB is a chord of a circle. Well, I'm famous for my very poor circles, but there we go. Looks more like a peach But let's maybe erase just a little bit over there. There we go. That's not too bad. Okay, so we have a circle, and now we want a line AB. So let's just draw one in. It doesn't matter where. There is a chord AB. And if I label that, we'll call this A and that B. I should get a pen rather than my finger, but let's try and see how this goes. Right, so AB is the chord of a circle, which also has a center O. So there's O. And M, it says, is its midpoint. So here somewhere, let's draw it in another color. Not that you can see, but there. There we go. So that would be the point M over there. Okay, there's M. And it says the radius from O is drawn through M. In other words, we're going to just draw a straight line all the way down there. Okay, it's drawn through M. Prove that OM is perpendicular to AB. So what we want to prove now is that this is a right angle over there. Okay, are you happy with that picture? So the question is, how are we going to prove that this is a right angle? Well, we're going to have to draw some other lines to help us. And this is something that Cambridge also doesn't do very often, is do proofs, but it's very useful to see how to prove things. So one of the things I'm going to do is I'm going to draw a line from O to A, and I'm going to draw a line from O to B, which are at the ends of that chord. Now both of those green lines have to be radii, okay, because they go from the center and they touch the circumference. So they firstly then are equal in length. That's something we can say about them. So let's mark them. Equal in length. The other thing that we can do is we can say that the line from A to M, or AM, must also be equal. So let's mark those to the one MB. And the reason for that is that they told us that M was the midpoint. In other words, it cuts AB in half. Therefore, AM and MB must be equal lengths. Now, thirdly, okay, you can see that the line OM is shared by these two triangles, the triangles AOM and BOM. Are you happy with those ideas? I know that M is sitting in a rather weird position there, but just make sure it is actually the point, the midpoint along the line AB. Now, this means we have two congruent triangles. Do you remember that you did congruency maybe in checkpoint or even in IG1? So let's prove quickly our cases of congruency. In this one, we have a side, side, and a side that are equal in both triangles. So let me just give you those sides. We say that AO is equal to BO. And the reason? They're radii. AM is equal to BM, and that's because we had that midpoint. And then we can say that OM is common. So that means it is shared between the two. And that gives us a side, side, side congruency. Now remember, if two triangles are congruent means that they fit on top of each other. And that means that they are equal in every way. Well, if you now look at the angle of OMB and OMA, we would have to say that those two angles are equal because they are the corresponding angles to each other in the triangle. But since they are on a straight line, AB, okay, they go along here, a straight line is 180 degrees. And the only way two angles along a 180 degree line can be equal is if they are both 90, because only 90 and 90 make 180. And those are the only two equal numbers that will make 180. So therefore, it means that both of these angles here are the 90 degrees that we proved. And there we have it. We've now proved that the angle that is created by a radius which bisects a chord will always be 90 degrees. This is an important proof to remember. You don't have to be able to do the proof, but you must remember the conclusion from the proof. All right, so that's question number 2. Let's have a look at question number 3. I'm clearing this away. Let's just clear the whole canvas. There we go. This is so much better than rubbing with those horrible dusters at school all the time. Okay, so let's have a look at the next one now. So question number 3 says that we have a center of a circle at the point 5, 3. And we also have a radius of 5. Now we've already done our circle formula, so you should be able to just give an equation for a circle with these parameters. Okay, what you should have said is that, if you've done this properly, let's just go back to the pen, x plus 5, it'll be x minus 5 because the point is 5. Let me just do that again. X minus 5 all squared plus y minus 3 also all squared must be equal to the radius squared. And what did they say the radius was? It was 5 units, so the square of that must be 25. This must be the formula for that circle. Okay, and now they ask this question. Okay, they say show that this circle cuts the x-axis at 1, 0 and b at 9, 0. Okay, well, if it must cut at 1, 0, it means that if I substitute the points 1 and 0 in for the x and y, then the equation must still hold true. So let's sub it in. Sub 1, 0. Well, what is 1 minus 5? It's minus 4, and minus 4 squared happens to be 16. So we get 16 for our formula. And if we put 0, we get 0 minus 3, which is minus 3, and minus 3 squared is 9. So we get 9. And does 16 plus 9 equal 25? Yes, it does. Okay, therefore equal right-hand side of equation. And since it's true, it means that we've shown that it is a point on the circle. The other one, well, same thing. It's 9, 0. And I'm sure you can substitute those values in and see that we get exactly the same answer. We get a value of 25 on the left-hand side of the equation, which equals the right-hand side. Now it says prove that the radius that is perpendicular to AB goes through the midpoint of AB. Okay, so what are they asking now? They're saying that if we join those lines, both of them which are on the y-axis, okay, on the x-axis, 1 and 9 on the x-axis, we want to prove, okay, that the radius that is perpendicular to AB goes through the midpoint of AB. All right, so what is the radius that is perpendicular, or what is the gradient of a perpendicular radius to this line AB? Well, this line AB, we already know, lies on the x-axis. You see what we've got here is a circle. If I draw it, let me just erase everything here first. So let's draw a Cartesian plane. We've got a circle which has a center, we said, of 5, 3. So somewhere around here, and we know that this goes through 1, 0 and 9, 0. So this point here must be the 1, and that point must be the 9. Okay, and sorry, my center is not so great. I'm actually going to just redraw this quickly once. Let's just make it a little nicer, because the circle must have a center there. There's my center circle, 5, 3. and here is the point 1 and 9. Let's mark this 5 and 3. There we go. Okay, so there's my circle that we've drawn, and we want to say that this radius must be perpendicular. Okay, that's the radius. Let's just make it, there we go. Okay, now, since it is perpendicular, it must be perpendicular to the x-axis, because the line AB runs along the x-axis. Okay, it runs along the x-axis. So that was A and that was B. These are these points over here. So that's my A and my B, and it is on the x-axis. Therefore, the radius that is perpendicular must have an infinite gradient. Remember that an x-axis gradient, the change in x would be 9 minus 1, but the y would be 0. So change in y over change in x would be 0 over some value, in this case, sorry, 8. Okay? But that means that for it to be perpendicular, it must have a 0 over there. And of course we can't divide by 0, which is why a vertical line has what we call an infinite gradient. Okay, that's something we did look at when we were doing our coordinates geometry. I hope you still all remember that. Now, let's see. It says that we must prove that the radius is perpendicular to AB, that it also goes through the midpoint of AB. Well, to go through the midpoint, it means that the change in the gradient, or the change in y over change in x, the change in x will have to be 0. Now, what is the radius value point? It is the center value point. It is 5, 3. For this to have a gradient that is infinite, this value over here must also be 5 along the x-axis. And the question is the value 5 the midpoint value between 9 and 1? Well, remember, to find midpoint, we add the x value, we go 9 and 1. That gives you 10. Half of 10 is 5, so definitely the x value must be that. And of course, being on the x-axis, the y value must still be 0, because 0 plus 0 is still 0, and 0 over 2 is still 0. And therefore, the point 50 must be the midpoint, and therefore it is proven that we now have the midpoint being 50. The midpoint of AB is the one that makes a perpendicular gradient with the center point. Okay, so that's part B. Now they say find the angle subtended at C by the minor arc AB. Find the angle subtended at C. Now C is the center, by the minor arc. In other words, for this one, we want to know what is the value of this angle at the center. Well, let's see. What do you think we should do over here? Okay, we do know that these two over here are 90 degrees apart, and we can actually work out the length now of one of the triangles. So this is 4 over here. That's the length, and we know that this radius was 5 units in length. Well, that means we can use some trick. So if you've got a calculator now, you can say, well, I know the hypotenuse and I know this x value over here. Therefore, I should be able to work out what the angle is over here, or even over there. Let's see. So if that's the triangle we're using, and we want to work out that angle at the top there, we would say that the sine of that angle would be 4 over 5, and we'd need the inverse sine to find the angle. Okay, so you should be able to do that on your calculator. I'll just grab my iPad here quickly and do it. This is so much more fun than teaching at school. I think I might do this more often. So let's have a look quickly. Let me just get my calculator here. Calculators are needed for trick calculations. So we want to inverse the sine of 4 over 5. Because remember, opposite that angle is the side 4 in red there, and then the radius is 5. So inverse sine of 4 divided by 5 equals, let's just see quickly, 53.13. Now, since we could do the same on the other side there, it means that this angle must also be 53.13, and if we just take the 0.1, we can say that the total of those angles are 106.26, or if you want to, 0.3. Okay, I want to show you something quickly, just as a matter of interest when you are doing these kinds of sums and you are rounding off. If you had found 53.13 and then rounded it off, you'd have got 53.1. Then you would have got another 53.1, which would have given you 106.2. But by not rounding off your answer, you actually get the answer 106.3 to one decimal place. And that is a more accurate answer to give. Okay, so don't round off and then give answers later, or do two rounding offs. Rather keep your main answers as whatever decimal figure you have, and only round off your final answer for exam purposes. This is going to be important for many questions, not just the ones we're doing right now. And then we've got part D. So part D says that the point D on the major arc AB. Okay, so in other words, point D must be somewhere along here, because this is the major arc that I'm drawing for you there in green. Okay, so that's the major arc. So D must lie somewhere on that arc of the circle. And it says it is on the major arc AB and DC. Okay, so the point DC. Now remember, C was the point at the center. So from D to C is perpendicular to AB. Find the coordinates of D. In other words, okay, the D must actually be the point that lies over here. It is a continuation of this line over here, because it must be perpendicular to AB. And it says find the coordinates of D, and hence find the angle subtended at D by the minor arc. Okay, in other words, they're going to say we've got to firstly find that point, and then we've also got to find this angle over here. Does that make sense? Okay, so we're going to have to find that angle over there. Now, some of your geometry should actually be able to tell you what that angle is, but we're going to find it and see if it's true. And for those of you who are thinking, let me remind you quickly that the angle at the center is always double the angle at the circumference. So we expect that angle at D to be half this value of 106.3. Well, let's firstly go and find what this point is. Now, being perpendicular, we know straight away, and you don't have to do too much calculation here, but it must be the x point of 5. And since this radius has to be 5 points away from the center, it has to be 8, because the 3 from the center plus the 5 of the vertical point climbing up there must take us to the point 8. So 5, 8 is the point that we are looking for. Okay, well, now we want to go and say, let's go and find one of these angles. So we could work in one of the triangles again. All right, so I'm just going to mark actually one of the triangles here. Let me see, this is a highlighter here. Let's use this triangle. Now we know that the two radii are both 5. We've already worked out the angle here being 106.3 degrees. What else could we do? Well, what I'm going to maybe try and do here is, just give me one sec.